Thank you for coming. And my name is Antonio, and I work on topologies. Well, this is the first really big change. We moved from map to topologies. I'm joking, but before coming here, I just had a speech in 2015, and it was called Maps in OpenNMS, what's new in the maps, and so on. And it was nice because I understand that most of the problem we have a clear understanding of the most part of the problems related to maps and topologies. So we decided to move from maps to move to topologies. This means something different, because a map is a representation of a topology. Okay? So a topology can have different representation, and a representation of the topology is a map. So let's go forward and start with this mot. This is a Genesis song. I know what I like, and I like what I know. It's for the people who is starting a project on maps and on network maps. Everyone has our idea of what is the network map, and it's very hard to let people be satisfied with your network maps. But this is an old theme that we are not going to discuss today. So come back to definition. So a topology has a set of vertices and edges. That's all. Okay? So it's just this set. So what does this represent is not important. So we started from this concept to build our topologies in OpenNMS. So this is another important step. What does enhanced linked in this concept? Enhanced linked is a daemon in OpenNMS that has the ability to discover information from devices. This information from devices are connection information, and we use these protocols to discover information. So CDP, LLDP, Bridge, OSPF, and ISIS. Okay, so we walk the SNMP agent, and we get the information for these protocols. What is important to understand here, that while topologies is a general concept, here we have a punctual information. So the data, so what means discover a topology, having a topology? We mean, usually we understand that we have the information of how is connected, or how is made our network. So which are the nodes on our networks, and which is the relation, the links between these nodes. But here we have an important problem, that this gives the local information. So these protocols, well, it's not true, but at the end, the MIB implementation for this protocol, MIB implementation for these protocols, give you only the local information. This means that give you the neighbor information of the device. So it's like to ask, how do you know which are your neighbors? And they say this one. Starting from this information, that is from this device here, in this time, and building a topology is a problem. Okay? Because, for example, you can have different views of the topology in different times and so on. And this is, I want to speak about, so why enhanced linked is important. Enhanced linked is not the only source of topology information. We can have different other sources of topology information. For example, we can consider il BSM as a business service monitor as a source of topology in OpenNMS. Okay, but enhanced linked provide the raw data. Okay, it's not raw, it's ra con la e. Okay, for you to use for getting topology. And the most important thing is that this data must be affordable. Okay, I spent a lot of time setting up, working last year on bridge topology. Okay, now I don't know if it's really interesting to speak about this, but bridge topology is very important to build topologies because you get the connection, for example, of the servers in a data center or other kind of a connection. Usually, the topologies of the local area network is a bridge topology. So what means bridge topology? A topology in which the protocol is the bridge forwarding protocol. Okay, you know what, everyone knows what is a transparent bridging. So bridging is just a technology over a local network that let the device be connected, okay, at layer 2 of his OSI table. So the model we use is the broadcast domain. So everyone knows that one part of the bridge topology is the ERP protocol, address resolution protocol, in which everyone, so if I want to connect to another device, so we have device A and device B, and this has what is called a MAC address. So if I want to communicate over this medium that usually is a wire but can be also a wireless network and so on, I need to get this information. So the bridge topology is the topology of MACs. Okay? The real difference between the other service, this is horrible. It's not. The real difference between the topology of the bridge topology is that if you want to topology, you have to make some calculation. So when you walk the device for the CDP protocol, you automatically get its neighbors. So it gives you the information about the local port connected to the remote port. Okay. And when you are on such device, what you have is the bridge forwarding table of, for example, the device. So usually you can have a device that is a switch. Okay, a switch has like many bridges. Okay. So, and the way in which he learns the device is that you have 2 ports, and he has forwarding rules for each port. So every Mac learned on this port, he knows that must be come back in this direction, so he has a rule for communication to the Macs here, and so on. And this is for every switch. So if you have another switch here that is connected to this one, so here is Mac A, and here is MB, and you have also a forwarding rule for MA here on this port. Okay, so when you walk, so the local information of the device is not enough to build the topology, because you know only the forwarding rules for this. So you have to rebuild, and you have to have a strategy to rebuild this topology. Okay, and this can be made with an algorithm documented. It's in a paper by Lowenkamp and others. Okay, so this tells you that speaking of topologies, and it's not easy, because this is the first example, just in a simple situation, in which the information from one device is not enough to build the network map. Okay, and you have to run an algorithm to rebuild the map. Okay, so this part is not interesting. So it's just for technical details, but we will find this on the user interface of OpenNMS. So usually we found that the topology is made by what we call broadcast domain, and inside the broadcast domain there are shared segments. Okay, so the topology is typically a tree with the root. Okay, so if you have a port attached to this port, when you build the topology, you can find so this algorithm is able to reconstruct the topology, but not completely. So what you can find is just not only one device, you can find several devices, so several Mac, and also several ports. So you can have bridges here and here at the same level. Okay, because there are situations in which you cannot reconstruct the complex structure, because, for example, here there is an hub. And attached to the hub there are 2 switches and so on. So imagine that in this you can have a complication as you imagine in this fact. So let's try to move to see how the topology appear in a real environment. So this is a test with a lot of devices, and these devices, so there is OSPF, ISIS, and there is bridge information and so on. So let's first of all check the nodes. So Tione A9K PE01. Okay. So here you have your node link detail. So this page is intended to display the local information by the device. So in some sense, this is not a topology. This is what we got from the device, rebuilt with some information. So you see that Tione A9K-P01 has no information, it's not a bridge, has no LLDP enabled, is a CDP, a lot of CDP information. Okay. You see on the left you have the name of the port, okay, the IF index, and the IP address is available. And on the right, you have the same of the other device with the name of the device. So this, if this is not clickable, this usually means that this device is not in OpenNMS. Okay, this is the information as we got from the CDP protocol, but we know that this information is there, but we don't have Andalo ME38P01. I'm sorry if I told this in Italian, as a connection. Okay? Okay. So there are no SPF link because it's strange, because the OSPF MIB is not enabled, because of course this device has OSPF. So let's go to class. Very similar device. So of course these are backbone routers. You have no bridge information, and here you have the information about the CDP, and you have also the information of OSPF. And you see that every link is also an OSPF link. So at the end, OSPF and CDP over this network will give you the same information. Okay. Of course, the protocols are different, and that's the router ID. Of course, I was not able to get the name, because what I have in OSPF is the router ID. Okay, OSPF is an IP very strictly protocol, and everything is an IP address. But here you have the router ID and the port, the IP address of the port that is connected to that OSPF link. Okay, LLDP. So let's try to go, if I can see, not here. So with this is the router. I don't know if it's the situation of this. This is the router of the LAN. So consider that this is a very, you have a backbone here with a lot of devices, okay, and so on. Then you have a couple of devices here which are connected to this device, and here you have a local area network, well, several local area networks, because there are VLANs, and wave bridge. Okay. So you see here that you got a different information about the device. First of all, Spiazzo. So this is a Spiazzo. Okay, has information. Where is the information of Spiazzo about the bridge? It's here. Okay. And you can find that we are able to detect a lot of information. So, and this is not what the devices see. It's just what we have calculated to be near to device. You see here that The first port is a connection with the catalyst, so it's a connection with the backbone. So the first port is this one. No, sorry. No, this is the first port is the bridge. So I'm sorry. So let me retry to explain. So this is a spiazzo. It's a router. Okay? This is connected to a switch, an Alcatel switch. And the Alcatel switch is connected to different on other VLANs. So the first is the connection on the Alcatel switch, that is the public network. This is another private network. You see that we don't have any other information because we don't have any device, but we have a list of MAC address and devices connected to that port. The second one, this one. Okay. Also, we have other different connection. Of course, which is so. This is something strange, but we don't want to speak about this. It's a protocol we does not support. Of course, this here's the connection to the backbone, because the connection to the backbone is done via a virtual interface that is made of 2 bridge ports. Okay, but I don't want to discuss because we do not support yet this protocol. So the interesting part is just the connection with the node ID 37. I don't know why it does not give me the name. So, and you don't be confused. This is the local port. This is what is called the port description, port IF alias. Okay, so the port IF alias is just the connection to Spiazzo SS01. Okay, and here you can get the other connection and so on. So it appears. Also, we have the LLDP enabled with it's our connection and so on. Okay. This is a first place where you can get in OpenNMS information about topologies. Okay. The other place where we can get information about topologies is in the topology map here. So, I don't know if everyone knows which is the concept of a map. I don't want to discuss about this, but we have a focal point. Okay, the focal point is decided dynamically by OpenNMS using a criteria of the most fastest ports. Okay. In any case, here is class, and here you look on the right, you have number 1. This means only one step behind the focal point. So to add the nodes to the maps, you can do different things. The first thing you can do is just to add the focal points, or otherwise you can increase the step numbers, okay, and you get all the topology of the network. This clouds means that there are multiple IP addresses connected to that port. Okay, I don't know if you can use, and then you can also get, I think it's a 6-level map and so on. Okay, 4-level map and so on from step behind. So this is a map. It's different from a topology. The same topology can generate different map, because if I can do this, it's just different map of the same topology. So I mean a different representation of the same topology. Representation is very important to let the people be happy, and usually it's hard. Okay. So this is how it's working now. Our situation. You see that we have here a search, so we can add nodes and so on with the status. So I don't know if everyone knows our map, our topology map that has been built. I don't remember, some 5 years ago, I guess, 2013. Yeah. Let me try to move. Wait a second. Yes, I'm very sorry for this, but I am an old man with an old PC. So, vabbè, IPNIT to media connects Max to IP. So when I was able to recognize the IP address of the device in OpenNMS, I moved to that. So let's come to what are we working on now. So we are working on what we call topology REST service. So what does a topology REST service? So we have an endpoint here over our REST. It's just topologies, and you can get the available topology. So the idea is that everyone can generate its own topology. But to do this, you need to create some things. So I have here an example. So I build only the CDP topology. Okay. And the build of a CDP topology, say if I do this, OpenNMS. So the idea is that we need to do everything. So if I do topologies, you can have only the CDP topology. I can do a stupid trick, and I can remove CDP. So this is something that is very important, is that these topologies are related to active service in OpenNMS. Okay. Actually, the only topologies that we are able to see is the CDP. If I want to see which is the CDP topology, just I do this one. So everyone knows what is this. This is GraphML. So we are deciding which will be the output of the topology. But a first step is just to write it in GraphML. Okay. So as you can see, this is a topology. Has its graph node with graph ID CDP and so on. In the same manner, we can build every kind of topologies, also mixed topologies. So what I can do, I can decide to registers for raw data from LLDP and CDP and put all together. Or I can register from the data or from OSPF and CDP and put all together. Or doing any kind of operation I want on my raw data to get information. In some sense, the only thing you need to do is, this is just was conceptually, to register to the topology service. So the idea is just, there are two kinds of registration to this topology service. The first is just a registration, and the second is a subscription. So there are two objects, two interfaces that do this, the updaters and T consumers. Okay, so what I can do is that if I'm an updater, I say, well, I own the CDP topology, and I send all the information about the CDP topology to everyone. Okay? If I am a consumer, I will receive this information. And I can use this information to build my own topology with a different behavior. Okay, so let's try to, this is, it seems a little bit scaring, but we can take a look at the code. Maybe it's more clear. So this is, I have a pull request here. Okay. And here is the changes. So what I have done is, oh my God, a lot of changes. This is not interesting. This is not interesting. Too many changes. Okay, so here is the main interface, is the so-called topology DIO. So the first is just something that I think we have to move to node DIO. Okay, and also the name is wrong because this is a service, not a DIO. In any case, you see here, you have a set of a string that gives you the supported protocols. Okay, then you can register what you call a OpenNMS topology updater. This means that I can, before sending information about topology, I register to this service telling, well, I am the topology updater for that protocol. And then also I can unregister it. Then I can subscribe, which is a topology consumer, and unsubscribe a topology consumer. Then we have a method that makes an update. This is for messaging. So what we mean is that actually the topology is built in memory from the request. Okay, so you get you create the request on the page, on the map, and then the topology is built, and then is rendered. Okay, we have the idea that when the topology, so because who is in charge of the topology is the topology updater, it can also send messages about updating the topology. Okay, if we look at the topology updater, how is topology updater? It's another interface. Okay. It has two methods. The first method is to get the topology. So this means give me the topology you have now, and the second method is just the protocol about the topology he owns. Okay. If you look at So the implementation is all here. So if you say get topology of the protocol supported, I check if the topology is supported, otherwise I throw an exception, okay? And otherwise, what I do? I get the updaters map contains is a map from protocols and updaters. So in this way, the service, I can ask for getting this information. So every time I need information from the topology, I ask the registered topology updater for getting the topology. Okay. If I go down, so there are, so these are the unsubscribe and so on. But what is interesting is, so get supported the protocol and so on. It's just, here is a forgot synchronized, noise here. So get node is removed. So here is the update method. Okay, this update method is called by a topology updater every time he wants to send a topology message. We don't know really what are this topology message. I guess they can be a variety of message we decide. Actually, it owns information about links and so on. We can see an implementation of this, hopefully. But very easy. He just, first of all, check if contains the protocol. Then he check if the updaters that this is the same he has registered. And finally, it just does this information. For each consumer for which the protocols he has subscripted, he calls the consume. So this means that when, so the situation is not bad. So I want to use to consume CDP topology updates. I am the CDP updater. Okay. This means that I own all the information about CDP topology. That's not work. It's better. This is horrible because so the CDP updater register to the topology service. I'm sorry, I have to write better service. Okay, so anyone else that wants to get the updates for the CDP updater must subscribe to the topology service for the CDP protocol. What is interesting that you can subscribe for how many protocols you want, and also the subscriber can be an updater. So if I want to build my map based on my topology, based on different data from from different topology updaters, I can do. So the responsibility, what I like of this is that the responsibility of making the calculation and sharing the information is devoted to one. If, for example, in my test environment, disable the CDP discovery, I will not get any information about CDP, so I will not get information about CDP topology. Also, if the information is persisted into the database. Because it is like to be active, something active to get you the data. Okay. Of course, this is a situation. So let me try to, no. Wow. So services is at the end. So let me come to the REST service. Okay. So this is the topology REST service. This is the service that gives the information about the topology. Okay. We have seen. So you see that when I get the, so you can see how I use the topology DIO. Get supported the protocol to string. Okay. Then I get the number of the topology supported. It's just a count. And here is the path supported the protocol like CDP, and I get the data. So what I do is, if the protocol supported I ask, I get a not found. Otherwise, I get the GraphML, and I build the GraphML. We can build different, for example, we can build JSON if we extend this to support JSON and so on. Okay. So this work has been done such this. First of all, I need an object to be shared with the other, and this object is the OpenNMS topology object. What is OpenNMS topology? Object is just a set of vertices and edges. Okay. And then it's not bad, this code, I think. It means it's readable. No, not so bad. So what is interesting is that you get the same, you get the topology from the topology DAO. It's always the same object. And the transformation of the object into the GraphML is straightforward. So once you have all these objects, you can have all simple way of getting the data. I should open Eclipse. Okay. I don't know what time is it. Maybe okay. Let me do this. I have a test to see, but I would like to stop here. Let me so the topology service, the C topology, and similarly I can build SPF and ISIS topology and so on. And of course LLDP topology. It's a little bit complicated to create bridge topology, but it works the same. And I just do a reference to the Young topology. That is a request for comment now. It is a standard to design topologies by the networkers. Okay, but at the end, we can build also Young topology with our strategy, but or just provide updaters for Young topologies. But it's not the. It's now actually of the scope of our work on topologies. So other topologies can be the BSM. So we can decide the business service monitoring can be a topology updater by itself, and then updates the topology in the same way. Okay, register and sends the information. And then I would like to say, any question? So, yes. Any question? Or if you want, oh my God. Yes.
Is this in Horizon 23?
This is in Horizon 23. It's just a branch from develop. Yeah.
Is it just a REST service that's not consumed by anything in the UI, or it's just there available for?
This is what we have called a proof of concept. So we are designing this because, first of all, the most important part of this is messaging, because we need to send the topology updates to our correlator service. Okay, because we need this to build correlation. And there are, if you look at the way in which I have built this, you can ask for all the information about the topology, having all the data. Or you can subscribe for updates, so that you get the updates. Maybe you can also, we can also build something that you can ask for specific data. For example, you can subscribe or you can get this, get this information about this node with the query string or something like that. We have not yet decided which is the direction. I think it's, there is also a test to show how it can work. But it's just a very easy way of sending this topology information to someone who registered it.
So it just sends the entire topology?
No. So actually, the implementation is that it sends the entire topology. But I have done all of this. But the idea is to send the updates. But this, there are some work to be done. But we have still not yet decided if this is the framework we want to use. It's just a proof of what we can do for sending this information. If we decided that this is interesting, then we have to find a solution to send information. If you look at the topology message, there are three kinds of topology message. One is new, one is update, and one is delete. So this means that this information is new, this information is an update information, and this information is a delete. So you have to delete this information of the topology. It's no more available. To do this, of course, you need to maintain somewhere the topology, because if you want to work with difference, you have to compare with someone else. And for example, the enhanced linkd is not working on this. So we have to introduce different things. So we have to find a way to be very effective on this communication. So consider, but we can do that. Actually, we do this directly onto database. So what we do is, I get the data from the device. I update the tables with the updated date, and then I remove everything is older. Okay, but as I remove everything is older, I can select everything is older, and then use this information to send to the protocol updaters. Well, this information is deleted. What is interesting is that we should, there is no information about the port. But GraphML uses ports. So a port is an element of the node, of course, because a switch has multiple ports, but every device has multiple ports. And the connection is made between ports. So the edge is an edge between ports. Okay. So the idea is to introduce port. So then you can send the message about deleting. It's more easy. So you can send a message about updating, for example, a link or something like that. But for deleting a new, you can decide to use ports or vertices. So this node has been deleted. It's no more supporting CDP. Or this port is no more in the CDP table. Remove it from your information or something like that. But it's something that must be designed depending on what are the requirements we have. But I think that this mechanism could work, should work if you do this, and then you can decide to register with whatever you want, Kafka or something like anything you want. Or just with events. You can decide to send events for this update message, then you get the message and you create events, or whatever you want to do. What I like is that if you want a topology, you need someone who takes responsibility of this. And all the information about this is by this one. So, and that's the way in which I designed it. This, actually, the information is a little bit spread in different parts of the code in OpenNMS.